over 70 doctoral researchers. We have a portfolio of 15 million pounds research portfolio. Last year, we raised nearly 4 million in research budget. Again, if you want to learn more about the department, about the ID, you're more than welcome to look in our website and wait for the book. Within the IDE, we have defined 8 research areas that the department, the institute is looking at, and the life cycle analysis and circular economy is situated nicely in there. We have lots of collaborations and parallel things we're doing with other teams, but we specialize on life cycle assessment and circular economy. I'm just going to talk a little bit about the team. The team is relatively new, started less than 2 years ago. When I started the team, I was privileged to I was asked to start the team, form the team, and when I did, I really focused on 3 things in mind: research, teaching, and innovation and impact. And I'm going to very, very briefly talk about these themes. Hope it won't be too overwhelming, but I'll try and be quick. So the team, again, started just around 18 months ago. We already have around 15 permanent members in our team. We have regular meetings and where we get our progress on our work, and we socialize together. Last year, we have submitted and supported 5 bids and grant applications. We have 2 running projects. One of them is we are part of a 5.4 million pounds project that's called Chile Hub. We have a whole work package where we look at life cycle analysis in school buildings. So that's one part of this whole project. We have 9. I actually think we have 10. I need to double check that. We have, let's keep it 9. Life cycle analysis in circular economy and regenerative design. I also expanded to regenerative design. PhD students, which is really great to see. We have an increasing number of students showing the increasing interest in this area of research. We have joined 3 international life cycle analysis and circular economy academic networks. We joined a network we're collaborating with some group of researchers in Delft, and we recently joined another pan-European group trying to form or write up a proposal for a Horizon Europe bid. So we're trying to expand our impact internationally, and we really focus on applied research, and we have collaborated with lots of practices. So we have Craig here with AHMM. We collaborated with Hawkins Brown, Bureau Happold, and many others, mainly London-based practices. So that's talking about research. Very briefly about teaching, I think the main point of pride that I'm really pleased about is we started last year the first whole life cycle analysis module at an undergraduate course that runs here at the department with the help of Craig. This is a double credit module, so students do it twice a week. Craig will expand on that in a minute. But this is that was a great moment for the team because it's the first time we have a life cycle analysis module in the institute. Otherwise, we regularly contribute to teaching life cycle analysis themes across the institute. We have 4 master programs and 2 undergrad two undergrad programs, and we regularly have guest lectures. Riam is doing some also helping and tutorials beyond the institute, but we regularly have lectures at the Bartlett. I last year gave a lecture to the entire Part 2 cohort, so 200 students. So we are increasingly showing our visibility across the Bartlett. We also do some lectures internationally, in both online and in person. So we are really getting more recognized with our expertise beyond the Bartlett. Last point I want to say about teaching is that we really promote research-led teaching. We have developed a couple of kind of digital calculators that focus on carbon. Actually, one of them was came up from students. Students wanted to know their own personal carbon footprints. So we developed this personal carbon footprint that is being used actually by students in the Bartlett, not even in the department, but Bartlett scale. And we have some other calculators that are used in our modules. So, and this is of course kind of being fed from our research, and we're really proud of that. The last theme I wanted to talk about is innovation and impact. So we really promote and put emphasis on innovation. I'm a big supporter of that. Just a few quick tools that we've developed. Hebert was a tool that was developed 7-8 years ago in collaboration with Hawkins Brown. This is an embodied carbon BIM calculator. It's a plugin for BIM that is free to use, by the way, still in the Hawkins Brown website, being adopted quite globally and with some really fantastic feedback. Pluto is something that we recently kind of launched. It's a sustainable real estate building configurator that focuses on optimizing for life cycle analysis and life cycle cost. And literally, I think last month, Riam here launched her kind of spin-off from her own research, LCA Jordan, which is the first embodied carbon calculator for Jordan. I think she might be expanding on that a little bit in a minute. So really kind of focus on digital tools and kind of releasing some of our knowledge out there to the industry. Last thing I want to talk about is the impact. We have been actively contributing to a range of standards and protocols, industry standard protocols and some legislation. Back in the days before CBC TM65 was developed, we were part of the steering group there. And Letty, the same thing. And recently, a few team members joined the UK Net Zero Carbon Building Standard. So we are actively focusing on helping on that as well, specifically on embodied carbon. But yeah, just to show that we are also expanding our impact other than in academia. We're trying to kind of help and support legislation and protocols. Right. So this was just a very quick introduction of the life cycle analysis and circular economy team. I will hand over to Craig, who will. So again, Craig is the head of sustainability in AHMM and an associate professor with us. Yeah, Craig, thank you.
Thank you. Thanks, everybody. As Ben said earlier, I'm the random EDB graduate you get this time. I see some names on the screen that I recognise, but as Yair said, I'm also here because AHMM completed KTP recently. We're talking about three things. HMM, the KTP we did with UCL, and then the module that we've set up in whole carbon assessment that I notionally co-lead with Yair, but in reality he does all the work. HMM are general architects. I'm, as you said, head of sustainability there. I did my PhD at the Energy Institute here in that room there. We had a table tennis table in this room at the time. I got really good table tennis as well as getting my PhD. And I've been working with Yair on BCR on the SBR undergraduate sustainable built environments, energy and resources for the carbon module. AHM are general practice, I should say. We do lots of different buildings across resi, making spaces, helps cater lots of educational stuff, and at the moment lots of office stuff. So the first thing I was going to talk about was our KTP that we did with IEDE. We started this in 2020, I think. So during the pandemic, the kind of genesis of it was through that process. And the project that we were focusing on was this building, which in Canada Water has not been finished. It's with British Land. It was a large, about 1 million square feet of commercial space with some leisure, which was a cinema, and then something else, and 2 residential towers of about 350 residential units to start with. And we got to thinking about this because my colleague had recently finished a large project in central London. We were thinking about 2019, we were having this conversation when the kind of public awareness of carbon and our impact on the environment was kind of coming to the fore. David Attenborough just chucked out that kind of mainstream documentary that kind of got people things. So we're thinking about what are the opportunities in this kind of development, this kind of commercially driven development. So the kind of aim of this was to understand within a commercially driven mixed use urban setting, what are the opportunities for net zero carbon buildings? And I have an ongoing relationship with UCL. AHM as a practice was born out of the Bartlett. All the founding members met at the Bartlett in the late 80s, mid to late 80s. So we are kind of throughout the practice, we've got lots of connections with UCL, but it was a conversation I kind of started with Dejan Momovic, who was my PhD supervisor, to think about how we might involve UCL and the expertise that we didn't have in practice to kind of interrogate, verify, and bring their kind of level of expertise into what we're doing. So we teamed up with the Bartlett, with Dejan and S-Band, our client British Land, and the rest of the design team got on board with this, providing us data, kind of insights into what we were doing, and Innovate UK funded part of that KTP. We started with, as all these things do, a proposal, net zero carbon and high density mixed use commercial development. And what we wanted to get out of this was some kind of understanding of what, as I said, the opportunities were for us as a practice, for our industry, lever point throughout design pressure we could apply to the rest of the design team, and then kind of what it might mean for a commercial practice such as ours in the future. So this is one of the outcomes of the document, but I think it's quite good to kind of summarize where we got to, what we started to look at, which was whole life carbon, operational energy, a carbon square, thinking about how we fit into the idea of a kind of architecture of efficiency, the embodied carbon performance gap. All this stuff is familiar to you. Bear in mind, this is practice-based research, 5 years in the making. I want to just touch on some of the things we thought about, which are all familiar to everybody in this room. Apologies, I've been teaching you to suck eggs, but we kind of thought about whole life carbon from an architectural point of view and how we can communicate these concepts to lay people within a large commercial practice who haven't talked about this stuff before, thinking about kind of whole life, about upfront, operational, lifetime embodied carbon, and these kind of concepts that are kind of alien to our colleagues. And part of that process working with UCL was to help visualize this in a way that we thought intuitively allowed us to make design decisions around all these concepts of whole life carbon in a way that our architectural colleagues could understand. So we've got RICS, A1 to C, A to C up the left hand, the vertical axis, life cycle of a building to 60 years and be hopefully beyond on the horizontal axis, practical completion here. So we've got our A1 to A5 upfront carbon here, our B modules, the orange line being P6 operational energy, the little lumps of embodied carbon under these things are the kind of reused maintenance, refurbishment throughout the life. We've got some dismantling and demolition, hopefully a big chunk of recovery, and then some kind of chunk of offset to get us to a net zero carbon building. This is a kind of diagrammatic version of that, but in putting this kind of visualization to our colleagues, kind of with the expertise underpinning it from UCL, it gave us a way and still gives us a way to talk to our colleagues about decisions we're making and kind of testing as we go. We broke stuff down. The RICS methodology obviously breaks things down by these kind of building elements. Turning it into really simple diagrams for our architectural colleagues helped us communicate this stuff, build this into our models. It gave us a language to talk to our architectural team about, so we're making these kind of renders and doing these drawings, but actually to turn that into kind of some quantitative information where we can pull out each of these elements, analyze these for embodied carbon. This has since turned into a kind of a facade tool, an embodied carbon facade tool, where we can pull out embodied carbon on an elemental basis, and then the kind of, I think there's a question I'm going to be asking until I die. Why is there so much aluminium, anodized aluminium on this facade architect? Can we use something different? But it allows us to really quickly identify the main source of carbon in any kind of architectural idea. We talked about operational energy a lot. All of these things visualized via graphics and then fed into that kind of life cycle chart, so we can see the kind of the steepness of that curve in architecture, but then always trying to bring it back to a kind of an architectural idea about what that means as a kind of architectural proposition What does it mean for how we design facades? What does it mean for how we move pieces of buildings around? How occupants control stuff? But being able to visualize as a life cycle carbon piece, architectural decisions has been very helpful. Something that we've gone on to work on after this KTP, using the toolkit that we developed during this KTP, is the idea of adaptable buildings, particularly all this stuff strapped to the ceiling of this building, which will get ripped out and put up again. But being able to use that visualization to see what happens if you make a building adaptable or not as a life cycle proposition has been really helpful. It's changing how our architects think about how they make buildings, how we use them, and how we can refit them responsibly. So we end up thinking about lean building. This is some work we did for Google, which we think about the building as a theatre, a stage set, and props. This stuff might be movable and disposable. This stuff might last a bit longer and be kind of need to be adapted, but the kind of theatre itself is like a permanent structure. So actually layering the building out like that, being able to apply different ways of thinking about the life cycle carbon attached to each of these pieces has been very helpful. That's a fit out for Google we did as a kind of outcome of that project. We thought this was really novel at the time. I think everybody had the same idea around about the same time, so not so novel. But the idea in construction, we are all taught as architecture students that time, quality, and cost are the contractual triangle. You sacrifice a bit of time to guarantee some quality and cost, or you might pay more for something delivered faster, or you might sacrifice quality to get something done quickly. What we wanted to do to introduce that as carbon as a kind of equal part of that diagram. Our research associate Simon Hathaway, who carried out all this work, insisted on a square. I thought it should be in a pyramid, but it was getting more difficult to draw pyramids, so it's carbon square. But this is our interactive. This is a tool. So what we developed as part of this process is a tool in which we can count the carbon, but we can also use this carbon square, or rather a series of interviews with project team members to generate a carbon square for your project, understand what the main drivers are, and adapt how we work accordingly. The outcomes were two things: delivering net zero in use guide for architects, which is published on our website and is available to use to download, and delivering net zero in use Excel-based toolkit. Our graphic designer has worked some magic and made it look not like an Excel-based spreadsheet, so it looks amazing. But it allows anybody to download that tool, generate a life cycle curve for their project, iterate, examine where the carbon exists, and change where, and hopefully deliver lower carbon buildings. It also has that carbon square tool within it as well. So as part of a kind of knowledge transfer partnership, developing these pieces of guidance, which are 10 sort of internal pieces of work for our architectural teams, underpinned, as I say, by the expertise that UCL brought to it. We've actually published these for everybody to download for free from our website as a means of kind of raising all votes and kind of supporting our industry to delivering this stuff. So it's been a kind of really valuable piece, and cynically from a publicity point of view, for you AHM, it has been really good, but I think we've genuinely added to the kind of to the kind of industry discourse around this stuff. Key lessons came out of it. I mean, again, probably obvious to everybody in the room, but performance-based modelling is kind of key. Clear and ambitious targets. That's one thing that came out of this. This is pre-UK Net Zero Carbon Building Standard, post RIBA 2030 challenge stuff, but just making sure those targets are in everybody's contracts and that we're aiming for them, and that it gives us a kind of laser focus on all the things we're trying to do. Thinking about those appointments, making sure people have got time in early enough across the design team to do the kind of iterative thinking that is requirement, communicating that stuff, early contractor engagement. Partway through the project we were working on, a contractor came in at stage 3, completely changed the structural system with a lower carbon version of it. Because we could visualize the carbon implications of that, we could see it was better, it was also cheaper, therefore it happened. According to the team, and then thinking about who we've got in the team for design team capabilities. Our toolkit, as I say, is downloadable from our website. There's a couple of QR codes after this, but there's lots of guidance. It looks something like this. You can click on things, upload your data. Your data can come from anywhere. It can come from one click, it can come from your own, it can come from HPAR if you export it from there. It can come from your own spreadsheets. You put it in there to kind of interrogate these decisions. And through UCL's kind of support, we got a really good outcome from our KTP. We got a certificate of excellence from whoever declares such things, which is a really good thing to happen. But I mean, a kind of hallmark of the partnership between UCL and HM and the kind of support we got from UCL. They're downloadable here. I don't know if these slides are going out, but I can leave those QR codes up there momentarily, or if the slides are going out, they can go. I move this thing. Oh, no, sorry. ATP, SBR, whole life performance. Very briefly. So, as Year said, the SBR undergraduate Sustainable Built Environments, Energy and Resources are a group of students who are learning about how to be sustainability professionals. So not necessarily built environment, but looking at policy, economics, and some built environment things. So a kind of wide-ranging skill sets, although very numerate cohort of students. The LCA module is the only one which is specifically about buildings. They do a city scale module. Our module is one of them that's about buildings. They are first years, so straight out of high school. And the module aims are to get an understanding of key contributions to life cycle of buildings, how to calculate and evaluate stuff, the things we've just been talking about, how to then iterate and improve a building's life cycle environmental performance, and then kind of talk about the concepts of circularity in the built environment. Two pieces of coursework we do. One is a group piece of coursework where we ask them to design a cafe in Regent's Park. Bearing in mind these are students who are straight out of school, they're not architecture students, they've never done this before in their life. So the learning curve is steep, and we're introducing them just concepts about how you put things together, how people might get into a building, as well as concepts of life cycle analysis. And then we asked them to do a second piece of coursework, which is a synthesis of everything we've learned over the lecture series and a further iteration of the design they came up with as a group, so we get kind of an idea of the individual understanding of the iterative, data-driven process in the coursework. We're introducing to these ideas, how carbon. As I say, they've never designed a building, they never thought about how a building fits together, never mind how much carbon is it. So it's a steep learning curve there. We introduced them to benchmarks. You mentioned LETI earlier, so we introduced the LETI benchmarks, the UK Net Zero Carbon Building Standards. So the idea of there's a marker for your building and how it might perform. We asked them to think about, so I was feeling charted out, so I put some pictures in. Where you get your materials for your building, where you get them out of the ground, think about that. How far they're traveling, what they're made of, what you're pulling out of the ground. What's the manufacturing process? Is it carbon intensive like steel? Is it something else you're doing? There is then a secondary manufacturing process in a factory somewhere. Where is that factory? What do they do? How do they make it? How is it put together? Think about all of these things. What's it then rolled through? What are the other kind of tertiary processes that happen to your materials when you're making a building out of them? Then how are you putting it together on site? Is it a kind of mess of collection of materials like this? Are you reusing bits of building and adding some new stuff in? What does that look like? How does it happen? How do you think about it? How are people actually making it? What's it like for people on site doing so? Are you putting it up out of the ground? Are you using a lot of concrete, like a carbon intensive monolithic thing like this, which might be a good thing, but how do you qualitatively assess whether that's a good thing or a bad thing? You're spending lots of carbon, but there are other qualities that come with that, which might be worth the carbon. So we're asking them to think critically about these decisions. And finally, how do you use it? How do you move stuff around? What does that kind of adaptive reuse look like over time? And then we ask them to think about circularity. Is there a material bank somewhere you can go and get stuff from? Once you've created this kind of base case carbon figure for your building, how do you reduce that? And that would be person to look for new materials or reuse materials from elsewhere. So in the final thing we get into is operational energy. We use PDA. Yep. Which is, that's right, isn't it? Yeah, PDA. That means several things, but yeah, in this case, it means passive design assistant, which is a tool Arab PH9 developed, which is a little one room energy model, really simple thing for them to assess the operational energy and the implications of where they put things, the windows, etc., so we can get an idea of operational energy. And then for embodied carbon, they use both a UCL tool and one click LCA, which we get a list for them all. So they're all kind of digging into one click LCA. So they're using kind of industry standard pieces of software. We're asking them to work with the RICS framework that we're all familiar with. We're asking them to think iteratively, so go through this process and then review, reduce, reevaluate the key project stages. So it's getting them to think critically and circularly about the design process. And at kind of 2 points. I'm going to finish in a second. The learning outcomes are, as I said, components of LCA, evaluating emissions over the life cycle and understand how the whole performance of the building could be reduced, so thinking critically. And the kind of course looks like this. As I say, it's a 10-week course, taking students who know nothing about buildings to designing a building and carrying out an LCA. We take them, I think, quite clearly through the fundamentals of the design process, what good design looks like, and real kind of basics of building design into LCA, what materials mean, what EPDs, material passports, etc. Then energy consumption in buildings, basics, estimating energy consumption, circular economy, beyond carbon, through to a kind of guest lecture and kind of case studies around this. All of these pieces are either delivered by Yair and I, and then supported by guest lecturers coming in to kind of introduce these concepts and things to the students. It is an incredibly steep learning curve, but I think it's been, in the 2 years we run it, I think it's been a successful process. I think we're creating students with a good understanding of this concept. That's me. We'll stop there. Thank you.
Excellent. Thank you very much, Greg. And our next speaker is Reham, who will explain a little bit, share a bit about her research.
There's loads of food there, Yair.
I'm not going to eat it all, so guys, feel free to, yeah.
Yeah. Hi, everyone. I'm Reham. I'm happy to share a little about my journey and my PhD research that I've been working on at IDE. And I believe I got really great experience at UCL starting from my first year, working on a project with the National Trust and IDE with Dr. Yair. That added a lot for me, working on embodied carbon of National Trust buildings, providing some recommendations for them. And then I got as well a lot of experience being as a PGTA at IETE and Energy Institute, working on some modules like making buildings with Yair and some other modules with different fields of energy data analysis and advanced machine learning. So I think I got a lot of experience throughout my journey. And even being a deputy at this research group added a lot for me because we were working on organizing and communication with the internals and even externals from industry academics. It added a lot as well for me. And to start my research project, my PhD research, that was about evaluation of decarbonization pathways for Jordan housing stock, embodied operational carbon buildings model. Basically, I go through the main method of my research and then the key findings of what I've done throughout this 4 years. So Jordan is one of the Middle East countries that located in the West Asia, and the dwellings represent around 72% from the total air stock. And it's actually one of the countries that's in a region that there is a lack of data sources. While I was working, it was a challenge for me while I was working on this case, and there's as well limited resources. So that's why so this research aims to investigate the whole life carbon reduction strategies. That's why I did some refurbishments toward net zero embodied operational carbon for these refurbished housing stock in Jordan. And from this aim, we can get 4 main keywords: the housing stock model, life cycle assessment, the refurbishments, then doing some optimization to get the final optimal refurbishment. These keywords that structured my research method, starting with a housing stock model that's needed as an input to pursue to the final result. So I go through each phase of this method, just showing briefly the main results I got without going beyond these results, because definitely I've done a lot of statistical data analysis, and there's 2 papers on this part of my method published. You can review it. Statistical data analysis for the data in Jordan from DOS data and other programming building constant data. And there's another paper that's generating the housing stock model in Jordan, because we don't have a housing stock. So that's why I needed this data to go through my research. Basically, I've developed 21 archetypes that develop based on like envelope and construction data that's needed for operational carbon analysis and the energy systems that are used for these buildings. As well as we need this for operational carbon, but for embodied carbon, we need data on the construction materials and the embodied carbon of factors of these building materials that are used in Jordan. So there is another gap of data that we have in Jordan. We don't have embodied carbon factors for building materials in Jordan. That's why I went through the calculation and estimation of the embodied carbon factors for building materials in Jordan. I went through this into 3 levels of research. I got some primary data from these main factories, from the most common materials that we use in the country for housing stock, and then secondary data for some imported materials, some assumptions for the data that we couldn't get directly. This is the after I developed these factors for the case of Jordan based on the data that I got. I developed this kind of calculator. This calculator was launched last month, as you said, so that you can just easily, the input would be the area of your building, and I have, for now, the first version, I have the main construction materials used for housing stock in Jordan. So you can put just the quantities per kilogram, and then it gives you the output would be the embodied carbon, the normalized embodied carbon, and the total embodied carbon of the building, with the percentages and the class of your building in terms of embodied carbon. And has free access, so you can easily access the tool. Okay, so the calculation, yes. You just press calculate. You can get the results in terms of percentages and the class of your building. So this was developed last month. Now going to the next phase after getting preparing the input data that's needed for the embodied and operational carbon analysis, I went through the life cycle assessment in terms of embodied and operational carbon and current and future weather. But now for current future, we get the results of embodied to operational carbon for the whole entire stock, 21 models with the total numbers of buildings within each of these 21 models. So this was the total embodied and operational carbon of the buildings. And this was the operational carbon in the current and future climate. And we noticed that there is a decrease of operational carbon. I would say the reason because 16 out of 21 of these buildings naturally ventilated. So there is no cooling system used. And in the future, there will be a reduction of the heating system that's used. So that's why we got a reduction. But in this case, we might face a discomfort future, like overheating risk. So that's why I've run another analysis for all this model, but just for one of these models that shows that there is an overheating risk in future climate for all of these archetypes. And that's why we might need to develop some strategies, even to consider the thermal comfort, then our refurbishments. So that's why I went through the refurbishment strategies in 2 levels again: passive measures, active measures, and the renewables. On passive measures, it was, I would say there is a huge image for all of these details and the U values and everything that I've suggested or developed as refurbishment scenarios. But you can go through it in details and you can just contact me. But I mean, there's a lot of details for each of these scenarios that were suggested for each of these variables in terms of level 1 passive measures, active measures, and renewables. And then after that, from these variables, I ran the simulation, the optimization analysis to get to the optimal scenario in terms of life cycle carbon, life cycle cost as well, thermal comfort. After going through the analysis, this is the result of one of these 21 models. So it shows that there is a capital cost with refurbishment for one of these models. So here's the capital cost and the operational cost that's reduced from the non-refurbished model in future climate, as well as the life cycle carbon. There is embodied carbon that has been added on the refurbished scenario, but there's a reduction in terms of operational carbon. So in total, there's a reduction in terms of operational carbon and life cycle carbon, life cycle cost. This has been calculated for 21 models, and then for the entire stock, that is a result of reduction of 63% for the refurbished model in terms of life cycle carbon. This reduction of life cycle cost in case of making this kind of refurbishment with achieving the thermal comfort, because it's ended by using the Kent cooling. So definitely we got to the same point. So this is overall my research, and here's my profile if you want to go through my publications for more details.
Thank you. All right. So yeah, Riam is in her final year, so that's very extensive piece of work. We're going to hand over to Marius, who's around midway in his journey.
Yeah, thanks. Hi, it's Marius. I'm my PhD here at the IED, supervised here by here. And essentially, I have these kind of brief things to talk about to you today. So first of all, we're going to talk about what really is a PhD, and then give you some quick background of what we're doing, the aim of our research, a fragment of our results. So most people would ask, is PhD a degree? I would say no, it's not a degree. It's just a journey of intellectual maturity, because throughout the process, you just gain skills and you reflect always on what you learn. And this essentially ties back with philosophy, because you get to ask what lies behind the surface. So you identify some patterns, you identify some trends, and then you try also to identify what substance leads to these trends. And also there's lots of opportunities whilst maturing to undertake some PhD roles, do some teaching if you like, attend conferences. I'm going to in September, and perhaps to Japan in November. And you also get to publish your work in journals, which is fulfilling, I suppose. And but I think the most important thing is that you get to claim responsibility for whatever you're doing, because you're the master of your own schedule. You have to deliver stuff, you have to manage your time. But on the deeper level, I think the most important skill is to distinguish the important from the insignificant challenges, because there's always drawbacks, there's always mistakes. You have to start again, and you get to at the end synthesize arguments effectively, going beyond the cliche. So my PhD is summarized in this picture. What do you think is wrong here?
For nutritional benefits of health.
Exactly. Yes, that's what we're doing. Essentially, we need to focus on carbon, just ignore all the other things. And on our PhD, we thought of focus on. So most of you are familiar with all of these documents. This sets the net zero strategy for the UK, for the EU, for the States. So to achieve all these decarbonization milestones, the electricity mixes in the UK and Europe and the whole globe will have to transform, transitioning from natural gas to renewable mixes. And this will be involved both in operational phases of buildings and embodied carbon through the manufacturing of materials. But at the same time, climate change is here. Temperatures are getting warmer, and this will affect the need for energy. Life cycle assessment is guided in Europe by these three documents, but all three of them do not consider currently grid carbonization for embodied modules and climate change for operational ones. And these are all the life cycle impacts of buildings outlined in ISO 15804. And the last question that might come up is, most of you would like to stay in business after net zero. Let's say we achieve carbon neutrality in 2050. We have to worry about something after that, I suppose. And so the aim of our research is to identify how dynamic considerations, climate change, electricity mix, and electrification transport affect the LCA results of buildings regarding the whole list of impacts. And this is important because if we achieve decarbonization milestones, some other impacts might come to light. And there's been some concerns reported around the trade-offs of environmental impacts, which means exactly this. So this is the carbon and land use impacts of UK's electricity mix on an annual basis, on a per kilowatt hour basis. So you see here 4 scenarios. You see that there's a consistent decreasing trend in carbon emissions, but there's 2 scenarios in the UK that show an increasing trend in the land use impact on a per kilowatt hour basis. And this is because there's 2 scenarios: consumer transformation leading the way that use more photovoltaics, and photovoltaics, solar panels have a higher land use requirement per kilowatt hour, and this will be translated at the building level as impact, depending on distinct material and aeronautical characteristics of buildings, and what we call the performance gap of environmental impacts. The last one is a term that we've introduced in a number of papers and we're trying to promote. Let's focus on the performance gap. So the performance gap up until now has been defined as the difference between the predicted and the actual building performance. We use dynamic simulations to obtain an indication of how much energy will be consumed by this building, and there's a domain called post-occupancy evaluation, and they just identify the actual electricity consumption, the actual energy consumption, and there's always a gap between these two. In analogy, there's a gap between your predicted environmental impact and the actual one, because there is always a mismatch between the actual case and the life cycle inventory. And what is essentially driving this gap is that LCA is a methodological framework, and as such, it just simplifies real phenomena. Its environmental impact is associated with an ecological process at a global or regional scale. Carbon emissions affect the globe in the sense that if you have the exact same manufacturing process in the UK and Germany, just because due to the global flow of carbon, if you emit 50 kilograms of CO2, then that does the same damage in Germany and the UK. But if you have the same manufacturing process in Germany and the UK for steel, let's say, you would have a different water depletion footprint, because the water scarcity in Germany and the UK is different, and this leads to different footprints across different ecological regions. So therefore, 2 factors drive this performance gap. It's the fact that for some impacts, there are geographically dependent characterization factors that are being used to quantify them, and the fact that localized manufacturing processes play a role in the actual environmental impact. So what can we do to drive this, to minimize this gap? So we need to have more geographically specific data. So for example, if based on the grid operator, the solar panels are to be placed on rooftops, then land use is not going to be an issue, as indicated by our analysis. And also, we also need to ask for some more specific location data from EPD and suppliers, because currently EPDs do not specify the location of the manufacturing plant and the extraction of the raw materials, and that's very important, because that way you can specify the proximity to water bodies, and to identify also the emission discharge roads, which ultimately can lead to using tailored life cycle inventories instead of generic ones. Thank you.
Thank you very much, Marius. Thank you, everyone. Yes, this kind of concludes our presentations for today. I'd like to join everyone who joined us and the speakers. And yeah, if anyone has any questions, we are still around, and happy to get emails for the ones who are left online. Yeah, thank you very much.
I've got some questions. I'm going to have to go in a couple of minutes, but I had a interesting tour of the Paradise building, which is Joe Jack. Well, it's not his building, but Joe Jack Williams was leading it, and we were looking at the fire consequences of certain things and the thinking about the carbon impact of the fire engineering things. So one of them is everything wooden had to be painted with fire retardant, which possibly takes away some of the impact of the wood. It's not totally clear. And the other one, which is probably worse, was the raised access flooring was put in, so separating you from the lovely wooden floor. And the design could have kept that away. And it's this bit which is difficult to get some of these tools that you might think this is the building, it's finished. Then the letting agent says we're going to stick in raised access flooring, otherwise it won't rent. So sort of whether you are kind of thinking of these sort of bits in your various tools that you've been involved in.
Can I go on that? Yeah, on one of our projects, our tool identified exactly that. It wasn't timber. We found it really difficult to get timber in, past insurers, etc. Joe did a very good job on that project, but they tested everything up at the BRE. On a project we had down in Croydon, steel frame, really standard construction methodology, steel frame, created tin deck, concrete. We were working with our tool to reduce the amount of steel in the frame. In reducing the amount of steel in the frame, we had to increase the amount of intrumescent paint we had to slap onto it. But through our tool, we were able to identify, because we put a quantity of paint into it, that actually the life cycle carbon saving was not there. Actually, you're better having more steel and less paint than less steel and more paint, because the carbon intensity of paint is actually pretty high. So we are able to get into that granularity with it, which is good. And the second part of your question was
Raised access flooring? Or?
Yeah, we try and reuse that. Well, so as I say, we try and think about how we use our buildings, how you put stuff in and take stuff out. Everybody wants raised access flooring because it allows you to get data, etc. underneath. Separating you from the kind of environmental.
That was the sort of design bit, really. Just,
yeah.
And Joe was saying as well, now we don't really put data under the floors. It's really the electrics.
It's air sometimes.
So can you work out how to do it? So in this building, the air is in exposed HVAC, but if it's only power, you think, right, can we really not design that a little bit better? Because you can actually stick in a bit longer cables and go to the edges. Or
others have done some stuff on this. So if you are going to put it in, make sure you can take it out. So what currently happens is the pedestals for the raised access floor sits on are adjusted to the height they need to be, and then they pour some resin in the top so it doesn't move when you put the thing on. Then of course when you take it off, you can't adjust it because it's got resin poured in it and you have to chuck the whole thing away. So what we're working on is getting it installed in a way that can be reused in the future, but before we can get rid of it. Sorry.
No, you're talking about the. Oh, sorry.
No. Well, okay, I had a question.
Just to respond to that, maybe.
Oh, okay.
You mentioned tools, and I think it's kind of a balance between how generic you are allowed to be and still kind of have a viable tool for people to use, for enough people to use, or how specific you are, and then you'll have many fewer users.
Yesterday it was really obvious how much extra carbon was attached to the fire safety thing. So sprinkler system was massive in this building. Yeah. And you're thinking that is difficult to include in these tools. Yeah. You have to put it in anyway, but it may be different for wooden buildings compared to concrete buildings. And that kind of difference is something to think about. But anyway, I'm going to go. Nice to see you.
Thank you.
See you.
Yeah, question for Craig. Yeah, I was wondering if how applicable this was to deep refurbishments or existing buildings. And then also, I was just wondering how holistically will life carbon is addressed across different design packages. So if you needed to change something like a heat pump, or is it kind of more specific to the architectural package?
So the first question, if we use in any building, it's totally agnostic for building type, sector, use. So, you know, if it's a refurbishment, you've just got much less in your substructure, or nothing in the substructure to put in, data to put in, so you're just looking at what you're doing. So we asked the design team to put into it, so theoretically we should be able to interrogate those decisions. But like Ben says, though, it depends how much thinking the MEP engineer, for example, has put into the sprinkler pipes, because if they're just putting a generic system in, irrespective of concrete or timber building, you're only going to get the same number. So it's prompts people to ask the questions of MEP people: is this actually specific to this building type, and the rest of it is a holistic thing? So it prompts the questions about the holisticness of the thinking, but it doesn't make it happen. You've got to. That's why one of the aspects was communication and the kind of capabilities of the rest of the design team, because you need people who are thinking holistically around this stuff, I suppose. But it prompts a question.
Right. First off, I'll just end the recording, and then we can have a chat and get some lunch. Okay.
Yeah.
Thank you very much, everybody. Appreciate